Hello, and welcome to the So You Want to Be a Marine Biologist podcast, where we learn about the ocean, share sea stories, and explore ocean careers. I'm your host, Kara Muzia. Let's dive into today's episode. Howdy. For today's episode, we're going to be breaking down scientific jargon. Specifically, we're going to cover what baseline data is and why it's important. Whether you're interested in starting a career as a marine biologist or are interested in knowing more about ocean science, this episode will have gold nuggets for you. What is baseline data? Marine biologists study different natural occurrences and learn how things work, but how do you know how things usually work versus a random, one-off, unusual occurrence? This is what baseline data aims to identify and distinguish. For example, we know that green sea turtles eat seagrasses because someone studied them long enough to know that typically green sea turtles eat seagrasses and not much else. This took different researchers around the world many years of watching green sea turtles mowing the grass or dissecting their stomachs to fully establish this fact. This is what we would call baseline data, or this is how things usually work data. There are different anomalies thrown in there, like sometimes the turtles eat algae, or sometimes there are small crabs and other crustaceans on the seagrass that also get gobbled up as the sea turtle is munching along. Every now and again, a turtle might get a little wild and eat a fish. This is kind of like the lawnmower accidentally gobbling up a forgotten tennis ball. This is outside the normal realm, but we only know this because the baseline data, or the fact that green sea turtles usually only eat seagrasses or algae, was already established. Make sense? Fun fact, green sea turtles eat so much seagrass, it turns their cartilage and fat green, which is how they earn their name. Baseline data is really important to establish the effects of something. For example, if you have a pollution issue that you think is killing corals, it's really important to know which corals are already living in the area. Other helpful factors include which species the corals are, how big they are, and if there are any diseases present. This is a really specific example. But if you're armed with this data, then when you think the waters are polluted, then you can check and see how the corals are doing. Are they still all there? Are there any diseases that popped up? Are they still growing? The answers that you find could help influence legislation, regulation, or public knowledge that pollution is bad and it's hurting this coral reef. Ideally, you'd want to study this area for a span of time long enough to establish the baseline. This could range from a couple of months to a couple of years, depending on the complexity of what you're studying. One really big example of this is when the port of Miami was dredged to make way for larger ships. There are coral reefs present near the port. There is likely more data, such as exactly which species of coral were present, which types of fish live there, if there are any coral diseases present. But for this example, none of that really matters because after the dredging took place, the reefs were covered up. The sand and silt that were churned up from the dredging process were carried with the current and settled over the reef, effectively smothering the corals. Now, if we didn't have the baseline data to know that there were in fact corals present before the dredging took place, then we wouldn't have realized the effects that dredging has on the local environment. Another example of this can be whale diets. We know that, depending on the species or type of whale, they eat many things in the ocean. Some whales have baleen as teeth. Baleen is made of keratin. It's the same substance that our hair and fingernails are made out of and looks like a stiff broom. So these baleen whales use this stiff texture to filter krill and other phytoplankton from the water. Toothed whales, such as sperm whales, will eat fish or squid, but nowhere in the whale diet is plastic. We know this because there have been people who have studied whales for years and have determined that plastic is not a part of their diet. Knowing this, it's simple to identify problems like plastic in the ocean and whales washing up with their stomachs loaded with plastic. The baseline data that whales don't eat plastic help identify the problem. I mean this and the fact that plastic has no nutritional value for anybody. I'll give you another non-diet example. There's a seaweed in Sydney Harbor called crayweed. It used to be prolific in the harbor up until the 1970s when pollution successfully annihilated the algae and in doing so brought down an entire habitat with it. There's been some efforts made to clean up the water, and now that the water quality has increased, there are efforts to bring the crayweed back. This is a wonderful story of two baselines. The first is that there was in fact crayweed and a thriving habitat. Then there wasn't any. This presence-absence data helped to spawn a movement called Operation Crayweed to get crayweed to grow in the harbor once more. Their baseline for starting this is there was none. And their Operation Crayweed is working. I do love a good success story, and I'll put a link to Operation Crayweed in the show notes. We've established that baseline data is important, but how do you collect this vital data? Methods can vary from project to project. For habitat assessments, transects are a popular method. This is what I did when I worked for the nonprofit Oyster Recovery Partnership when I was diving in the Chesapeake Bay verifying oyster habitats. We'd lay 200-meter transects and then dive them end to end, noting bottom hardness and any organisms, plants, animals, and alike that were present. Quadrats are also popular. Quadrats are usually a square of PVC piping that is placed onto a study site. These are popular for coral and seagrass surveys. The observer would look at the quadrat and see which species are present and in which quantities or what quantities are in the quadrat. There are different scales and ranking methods used to quantify what is being observed, depending on what you're looking at. The observations are usually recorded in a datasheet underwater. Yes, you can write on a piece of paper underwater. It's like magic, but it's science. Reef Environmental Education Foundation, uses a technique called the roving diver technique. For example, if you go on a dive and saw 30 blennies, small little fish, you'd record this in their system along with any other fish species that you've observed on your dive. As an aside, if you are a diver or would like to become one, I highly recommend you check out Reef's website and learn how you can contribute to science on your next dive. I will put a link in the show notes for that as well. Back to my blenny example. Now, if blennies had never been recorded at the site, or they were recorded but only at certain times of the year, the data that you collect can help researchers understand different habits of this fish. This is why baseline data is so important. You can't understand if something is normal or not if you don't already know what the normal or baseline is. It's like a baseline on your health. If your resting or baseline heart rate is usually 55 beats per minute, but you check it and it's up over 100, you know something's going on. Did you just sprint a mile? Drink a load of coffee? You know this isn't normal, so you're able to research and better understand what's going on. Make sense? So baseline data is pretty important. The more we know about our natural environment, the better we are able to take measures to protect and conserve it. What can you do to help this? Do some of your own research and collect all the data. Check out citizen scientist projects such as Reef Roving Diver Program that I mentioned earlier. See if there's a research project in your area that you can help with, or take a trip and contribute to science while traveling. There's an online database called Project Baseline that you can log your findings in, or you can start your own. Our oceans and the natural world are one big phenomenon that are only partially explained. Science and studying our oceans better helps us understand how the ocean functions and where we can fit in. Baseline data is the starting point for understanding. Now, I have a challenge for you. Find a research project that intrigues you. It can be with sea turtles, seaweed, whales, corals, oysters. Pick a topic and then ask your favorite search engine to find out more about it. Learn about that project, its scientists, and how they're collecting their data. Guaranteed there's a little factoid that you could either use now or tuck away for future knowledge. As always, I'd want to hear from you. Did you find this episode helpful? Is there other sciencey jargon that you'd like broken down, or are you interested in covering a different topic? Leave a comment below the show notes or email me. I read every single one. Thank you for listening to today's episode. If you enjoyed it, please take a moment to subscribe to our channel. It helps other ocean enthusiasts find us. And we'll catch you next time on the So You Want to Be a Marine Biologist podcast.